Hello students, in previous lecture we have studied about the different types of quadrilaterals and their properties, and few of them properties we have proved with in the form of theorem, and as well as the examples which is based on the properties of different types of quadrilateral, that is parallelogram, square, rhombus, trapezium and rectangle. Then today we are going to discuss about the property of triangle. Then see here, triangle ABC, in which P is a midpoint of AB and Q is a midpoint of AC. That means point P and point Q are the midpoint of two sides of triangle, and here the segment which joins to the midpoint of those two sides of triangle, which is parallel to the remaining side that is BC. That means here the property which is known as midpoint theorem of two sides of triangle, and then we have to prove this property. Then see here, first of all we have to remind that property, that is, see here, the segment which joins to the midpoints of two sides of triangle which is parallel to remaining side and as well as, that is, half of the side, that remaining side. Then see here, I am going to repeating or reminding this property again here. See here, in triangle ABC, point P is a midpoint of AB and point Q is a midpoint of AC. Then PQ is a segment which joins those midpoints of two sides of triangle, and that PQ is parallel to the BC, as well as that PQ, the length of that PQ is half of the side BC. That means if BC is of 10 centimeter, then PQ is of 5 centimeter, as well as if PQ is of 7 centimeter, then BC is of 14 centimeter, and those property which we have to prove here. Then see here, we have to write the given, that is, in triangle ABC, point P and point Q are the midpoints of side AB and side AC respectively, as well as here the remaining side of that quadrilateral is BC. Then we have to prove that the line segment which joins that midpoints of two sides of triangle, that is, to prove that here PQ, which is parallel to BC, as well as here PQ is 1/2 of BC. Then we have to prove this property. Then see here, again we have to write that in triangle ABC. PQ is a segment which joins to the midpoints of two sides, that is AB side and AC side. But here we have to do some construction. That is, here we have to draw the segment, that is QF, and here such that P dash Q dash F, and that is PQ congruent QF, and we have to join or draw the segment CF. Then see here we have to write the construction, that is here point F is taken on side PQ such that P dash Q dash F and PQ congruent QF, and which we have to join or draw CF. Then see here in proof, in triangle ABC, that is P is a midpoint of AB, therefore here AP congruent BP, AP congruent PB, as well as Q is a midpoint of AC, therefore here AQ congruent QC, that is AQ congruent QC, and here therefore in triangle APQ as well as CFQ, here in triangle APQ and triangle CFQ. See here in those two triangles, here PQ congruent QF, PQ congruent QF, that is the construction, as well as AQ congruent QC, that is AQ congruent QC, that is given because Q is a midpoint of AC, as well as see here angle AQP congruent angle here CQF, vertically opposite angles, therefore triangle here APQ congruent triangle CFQ by SAS test, and see here those two triangles are congruent, therefore we can write that here the angle, here angle A congruent angle QCF, that means angle PAQ, therefore angle PAQ congruent angle here QCF, because corresponding angles of congruent triangle, as here those two angles are congruent, then we can write that AP parallel CF. Therefore, AP parallel CF, because alternate angle test here, and as AP congruent CF, then AB means AB parallel CF. AP means AB. Here parallel CF. Let this equation number 1, because here A dash P dash B, and here as well as here AP congruent CF. AP congruent CF, because those two triangles are congruent. Therefore, AP and CF are the corresponding sides of congruent triangle. And here, but AP congruent PB, but AP congruent PB, that is given. Therefore, here AP congruent CF and AP congruent PB, therefore PB congruent CF. And let this equation number 2. See here that AB means PB here. AB, that is AP means AB, and AB, that is of PB, because here as AP parallel CF, AP means AB parallel CF and AB means PB. Then let this equation number 2. See here from equation number 1 and from equation number 2, PB parallel CF as well as PB congruent CF. See here PB and CF are congruent as well as PB and CF are parallel. Then therefore quadrilateral PBCF is a parallelogram. From equation 1 and 2. Then see here as PBCF is a parallelogram, therefore PF parallel BC. PF parallel BC, that is property of parallelogram. Property of parallelogram. But here PF means PQ parallel BC. But PF means PQ parallel BC, because P dash Q dash F. P dash Q dash F. And that is the proof. See here PQ parallel BC. One of the property which we have proved here. One more property, that is PQ is equals to 1/2 of BC. For that purpose, first of all, see here as PF congruent BC. See here PF congruent, here PF congruent BC, because that is the property of parallelogram. That is the equation number 3. As PF congruent, because opposite sides of parallelogram are congruent. But here PF congruent BC, but PF is PQ plus QF. PQ plus QF is equals to BC. But here QF and PQ are congruent, but PQ congruent QF. Therefore, here this equation 4 becomes PQ plus PQ because QF and PQ are congruent. Therefore, PQ plus PQ is equals to BC, and therefore 2PQ is equals to BC. Therefore, PQ is equals to 1/2 BC. That is the proof of this theorem. See here, PQ 1/2 of BC. That is the midpoint theorem of triangle. Then we can solve the examples which is based on those property from practice set 5.5. And see here, there are few examples which is given in the practice set 5.5, which is based on midpoint theorem as well as the converse of midpoint theorem of triangle. Then the example which is given in the first question, that is, see here triangle, here triangle ABC is given, in which X is a midpoint of AB and Z is a midpoint of AC and Y is a midpoint of BC. Then, and here the side AB, see here in question number 1, in triangle ABC, X, point X is a midpoint of AB. Point Z is a midpoint of AC, and point Y is a midpoint of BC. And here the triangle XYZ is drawn, and here AB side which is given here, that is of 5 centimeter. AC which is given of 9 centimeter and BC which is of 11 centimeter. Then we have to find out the lengths of XZ, YZ and XY, and as well as we have to find the perimeter of that triangle XYZ. Then see here, focus on the figure and we can use the midpoint theorem of two sides of triangle here to solve this example. First of all, see here, X is the midpoint of AB and Z is the midpoint of AC, and the line segment joins to those two points, midpoints of those two sides, which is a parallel to BC, as well as it is half of the side BC. Therefore, here we can write that XZ is half of BC, because here midpoint theorem of triangle and here therefore putting the value of BC, that is 1/2 into BC, which is given here 11 centimeter. Therefore here XZ is equals to, that is 5.5 centimeter, as well as here Z is the midpoint of AC and Y is the midpoint of BC, that is given here, and therefore YZ is a half of the AB. YZ is half of that AB, and here the length of AB, which is given here, that is of here YZ is equals to 1/2 of AB, that is of 5 centimeter. Therefore YZ is equals to 2.5 centimeter, as well as here X is the midpoint of AB and Y is the midpoint of BC. Therefore XY is 1/2 of AC. Therefore XY is 1/2 of, that is AC, and here AC, which is given of 9 centimeter. Therefore XY is equals to 1/2 of that AC. Therefore here XY is equals to 4.5 centimeter, and here midpoint theorem of triangle is used in this example to find out the values of XZ, XY and YZ, as well as perimeter of triangle XYZ is equals to XY plus YZ plus XZ. Therefore here XY, that is 4.5 centimeter, plus YZ, that is of 2.5 centimeter, plus XZ, that is of 5.5 centimeter. Then here the total of those all, that is 12.5 centimeter. Therefore perimeter of XY triangle XYZ is equals to 12.5 centimeter. That is the example which is based on, that is midpoint theorem of triangle, two sides of triangle. Then there are few more examples which is given in the practice set 5.5. You should try to solve those examples and you should write the midpoint theorem and its converse in your notebook. Here you should solve also the examples from problem set 5, and here the topic get completed. Thank you.